Has anyone ever told you this before? Those old laptop chargers that still work can actually be reused and turned into a low-power soldering tool. Now, don't let the words low power discourage you, because that's exactly where the advantage lies. Low power doesn't mean it can't get the job done. It's actually perfect for soldering small metal parts together securely without damaging them. Before we get started, take a moment to check whether your charger is still working properly. If you want to be more precise, you can use a voltage meter to confirm that it delivers a stable output of around 20 volts. Once everything looks good, you can go ahead and follow along with the steps shown in the video. Sounds interesting already, doesn't it? All right, let's get started. After taking some time to check things carefully, I found that this laptop charger is still working perfectly. So the first step is to extend the wires on both ends of the charger, making it easier to handle during soldering without worrying about the cables being too short. To keep things easy to identify, I'll connect a red wire to the positive terminal and a blue wire to the negative terminal. Here's a small tip for anyone new to repurposing electrical devices. Don't forget to wrap any exposed connections with electrical tape to keep things safe and properly insulated. This is an alligator clip, and I'll connect it to the negative wire of the charger. Its job is to hold the workpiece firmly in place and maintain a stable electrical connection during soldering, so you don't have to keep adjusting it by hand. Next, I've got a basket full of old spark plugs. Normally, these are used in engines to create the spark needed for combustion. But in this video, I'll pick a suitable one and repurpose it as a holder for the custom soldering tip. It helps keep the tip firmly in place, while also assisting in retaining and transferring heat during the soldering process. And at the same time, I also have a 2x14 terminal block. I'll remove one of the metal connectors inside and use it as an intermediary piece to link the threaded end of the spark plug with the custom soldering tip. It probably won't come as much as a surprise if I make use of the carbon rod inside this old AA battery to create a custom soldering tip. In its original role, this carbon core acts as a conductive material inside the battery, allowing electric current to flow steadily during operation. Thanks to that property, it can also handle electrical flow quite well when repurposed. Another advantage is its ability to withstand high temperatures without melting or deforming easily, which makes it suitable for applications involving heat. Unlike softer metals, the carbon rod doesn't quickly lose its shape, so it can maintain a stable tip during soldering. It also heats up in a controlled way, helping focus the heat right where it's needed, especially when working with small metal parts. In this setup, the carbon rod becomes a simple but effective soldering tip, easy to shape, reasonably durable, and surprisingly practical for a low-power DIY tool like this. With this short piece of wire, I'll connect one end to the threaded tip of the spark plug and the other end to the threaded body. The goal is to create a direct path for the current, allowing it to circulate more efficiently through the spark plug. Thanks to that, the heating effect becomes stronger and more concentrated, helping the tip reach working temperature faster and maintain it more steadily during use. This approach also reduces energy loss along the way, making the whole setup feel more responsive, even with a low power source. This method is commonly referred to as a short connection. Next, I've got a larger alligator clip that I'll repurpose as a handle for this DIY soldering tool. It gives me a better grip, keeps my hand at a safer distance from the heat, and makes the whole setup easier to control while working. To really verify how effective this setup is, let me quickly remind you of its key advantage. It's designed to join small metal parts together without damaging them. So stick around and watch these simple test examples all the way through. Then we'll draw some conclusions together. And after these quick tests, I'd say the result is pretty clear. From something most people would throw away, we've made a simple tool that actually works. Not flashy, not powerful, but precise, controlled, and surprisingly reliable for small jobs. That's the whole point of DIY. Making the most out of what you already have. If this sparked an idea, try it yourself, and I'll see you in the next one.